Ladies and gentlemen, please welcome Chief Technology Officer and Senior Vice President of R&D VMware, Steve Herod.
Hi, can you hear me okay? Thanks. I just wanted to take a quick minute. I was very happy to get the chance to introduce the Cisco Super Session. This is the first session after the keynote. Hopefully you got a feel for where VMware is going. And Cisco is obviously a very tight partner for several years now. And most people would say initially they're a partner just on the networking side. But you'll hear shortly, it's certainly about not just the networking, it's about the compute, certainly about security, and really realizing the same private and hybrid cloud model. On a personal note, I'm very happy to do this introduction because it's one of my good friends. Ed Bugnon and I were office mates, 17 years ago at Stanford, and have kept in touch quite a while over time. He's a great speaker, and I think you're going to love what you have to hear here. So please join me in welcoming the CTO for the SAVBU, Ed Bugnon.
Good morning, everyone. I hope you enjoyed the presentation from Paul and from Steve as much as I did. So for the next hour, I'm going to give you an overview of where Cisco is heading and the innovation that we have, and we're driving in the data center in the context of this phenomenal wave of virtualization that is upon us. This is actually the third time that I'm giving the Cisco Super Session at VMworld. So I thought it was actually important, before I talk about the future, to just revisit some of the high points that we did in the prior sessions. The reality is, once you've been doing something for a number of years, at one point you have to deliver what you promised. So this is a little bit of the reality check. And when we started this 2 years ago, the real focus was on delivering a set of infrastructure solutions in the network and in the platform to help customers accelerate their journey to a virtualized data center and now to the cloud. And so as we revisit this, it's worth thinking about how well we did. Well, in 2008, we announced the Nexus 1000V at this show exactly 2 years ago. We got the Best of Show award. It was really the first time that the industry was able to come up with a solution that combines the innovation of virtualization and virtual switching with the existing practices of the underlying network and the network management. And the product is the Nexus 1000V. Once you forget all about sort of the features that we bring in and the richness and the robustness of the NXOS-based implementation, the real value of the Nexus 1000V is that it provides a solution that bridges what's otherwise an operational gap between the virtualization team and the networking team. At the end of the day, it's providing you a common view for different teams to work better together. And that's the big theme. It's also the success of the Nexus 1000V. So at Cisco, we tend to think of our penetration in the business in number of ports sold. That's the metric in the networking industry. By our estimate, we've licensed over 1 million virtual ports of the Nexus 1000V with the vSphere platform. A great number of referenceable customers that really always go back to the value of providing a better operational model, providing a bridge between the server team and the virtualization team. The cloud is not going to happen if we have gulfs. The cloud is going to happen if we create the appropriate bridges between all of the appropriate constituencies in the data center. So that was 2 years ago. And then last year, the big focus of Cisco at this event was obviously the Cisco Unified Computing System, which is our compute platform, which is a convergence and a unification of networking and computing optimized from the ground up for data center deployment and for virtualization. We actually got an award from this show also last year, but more importantly, over the past 12 months, we've acquired over 1,700 customers. There was some degree of skepticism when Cisco first signaled that it was going to enter the server business. I think it's fair to say that as we're about a year into the availability of UCS as a commercial product, that those doubts are now way past us. We have 1,700 customers. One of the things we're probably most proud of is we've created an ecosystem of ISVs that are writing solutions specifically for UCS. Not just VMware, but a whole ecosystem of partners delivering automation and management solutions onto the platform. And then from a commercial perspective, we create an extensive network so that makes UCS available over a broad set of certified partners. And then last but not least, we didn't just enter the business as a server vendor. We entered the business by providing the best server possible for data center deployments. And we have 10 benchmark records to attest to that. And throughout this presentation, I'll go through some of the key proof points of our leadership on the technology side, as well as key elements of the roadmap. So this is actually a packed session. I want to cover 4 big themes. The first one is to give you a sense of where UCS is from a momentum perspective, as well as some of the technology innovation that we're working on at this time. Then I'm going to give you an overview of sort of picking from the very broad networking portfolio of Cisco, of some of the key innovations that we've introduced over the past few months and shipped over the past few months that are really designed to improve a virtualization-centric deployment of application workloads. And then the big announcement today from Cisco is the launch of the Cisco Virtual Security Gateway. This is a security solution designed to run on a virtual platform and designed to secure the virtual platform in a virtualization-centric and virtual machine management-centric way. And then finally, I'll close with some thoughts about taking the solution that we have with the Virtual Security Gateway and driving all the way to the deployment of scalable cloud services. If you go back to the presentations in the keynote earlier today, it's really about this transformation to the cloud. It's about multi-tenancy, but it's also having a very rich set of services that are there to support the deployment of applications in virtual data centers in the cloud, whether it's in the enterprise, publicly, or in some hybrid model. So let's start with UCS. And this is actually not coordinated or planned, but a year ago, because you saw nearly the same picture in Paul's presentation, a year ago, we powered the bulk of the infrastructure for the IT-led labs. And as was rightfully mentioned earlier this morning in the keynote, this has all moved into the cloud and actually moved largely to Terramark. And Terramark is one of Cisco UCS's referenceable customers. A very strong relationship and partnership with Terramark in deploying our technology. And some of the key aspects of the deployment of UCS in the Terramark network is that Terramark is actually running a global network throughout the Americas, and that we are present in multiple locations with instances of UCS deployed at scale. And some of the value that Terramark got out of the deployment of UCS is first around the reduction time in provisioning new physical capacity. When you're bringing a new server platform to install ESX and vSphere on it, this is, if you do it in a traditional manner, a complex operation that could be measured in days, 8 days in their case. And with the combination of the automation capabilities that are brought into UCS, the provisioning time is now brought down to about 30 minutes. So that's one of the key aspects. The other key aspects of UCS for an operator like Terramark that runs things globally is the centralization of the configuration state and the policy information that specifies the relationship between the hardware, the firmware, and the network, what we call our service profile, and all of the policies specified in UCS Manager. Really there to simplify the management of this distributed environment, including the management of workloads or the maintenance of consistent policies across a distributed environment. So Terramark is one of our referenceable customers and one of our great partners for UCS. But this is not just a platform to be used by service providers. As a matter of fact, we have a number of great customers and great case studies that have been published in enterprise deployments of UCS, as well as service provider and cloud-based deployment of UCS. So a very broad list. This morning, Paul announced the first set of vCloud certified partners. We were participating with VMware and collaborating with VMware on together with the beta partners of vCloud Director. And beyond Terramark, we have 3 other common customers that are using the UCS infrastructure to deploy vCloud. So not only are we working with VMware from a technology development perspective, we're also working very closely with VMware to make sure that our solutions can be integrated in the field, in customer environments, as seamlessly as possible. There's something else that happened over the past 12 months, above and beyond the transition to the cloud in everyone's mindset. It's the fact that fundamentally the architectural trends have shifted and that virtualization has now reached a level of performance and density that, quite frankly, very few people had anticipated. And what these 2 charts illustrate is, starting in January 2009 until now, is the progression of the all-time record for the VMware benchmark in either the 2-socket configuration or the 4-socket configuration. And what you see is that the growth has been greater than 240% in one case and greater than 270% in the other case. So that basically means that the performance and density improvements have more than tripled in about 18 months. Now, that doesn't happen every time. That could be explained because of the innovation from vSphere and then 4.1, and on the software side, and then the innovation on the hardware side with the introduction of the Intel Nehalem line, the 5500, the Intel Westmere line, and then most recently the Intel Boxborough EX line in dual socket and quad socket category. And the important message here is that if you are virtualizing, then your boats will float with the rising tide because you can take advantage of these architectural trends. If you're not virtualizing, the performance and efficiency of your data center actually went down in the past 18 months for practically all types of workloads that you run bare metal in a data center today. So this is an industry statement. Now, one of the reasons why we've studied this in great amount of detail is this is also one of the proof points of the technology leadership of Cisco. Not in this environment. Not only do we break a few of those records, we actually broke 5 records using 4 different blade technologies at different points in time to get the all-time high 2-socket or the all-time high 4-socket score at one point in time. So as the great Yogi Berra once said, right, I always thought this record would stand until it was broken. Right? And that's actually a true statement, particularly in this industry. These records will keep, the performance curves are still going to go up. What's important is to be able to deliver on a sustainable basis performance leadership. And the only way you can do that is if you have the appropriate balanced architecture. And that's where all of the investment that we did at Cisco from an engineering perspective in building UCS, driving a unified low-latency 10-gig fabric at the core, focusing on the I/O subsystem, focusing on the memory subsystem, focusing on the power and thermal design, has led us to these leadership positions. This did not happen by accident. As a matter of fact, if you look at where things are today in terms of what's been published, we're actually publishing today the all-time ever VMware score, 76.1. For those of you who sort of, it's always a good exercise when you come back to the show, go back and look at the VMware scores of the servers that you're currently running in your shop. That will give you a sense of how things have progressed in the industry. 76.1, we're using 51 tiles. And 51 tiles means there are 306 VMs that are running concurrently in the environment, really pushing things at the limit. So that's the all-time top score. The other one I want to highlight, it's actually from an enterprise perspective and service provider deployment even more important, is we have the top score overall in the blade form factor. And we actually have it by a mile. Well, not quite literally speaking a mile, but we're 22% faster than the second best blade architecture. And that is directly the result of the balanced architecture, the hardware design with a focus on power efficiencies and a good thermal capabilities that gives us the ability to run high-performance solutions at scale in a balanced environment to get the most efficiency out of your systems. Now, there's another theme in UCS which has been key to the success and the adoption of the technology, is that we've not only built a unified fabric, innovating at the fabric level with technologies such as our fabric extender capabilities. It allows us to scale the fabric into chassis seamlessly. But we've taken the concept of extending and virtualizing the fabric all the way to I/O adapters. And the Cisco Virtual Interface Card shipped in February of this year, so between the two VM worlds. And we've been extremely pleasantly surprised by the adoption of the technology. It's a native 10-gig end-to-end solutions for both Ethernet and HBA capabilities. It obviously implements an HBA capability using the fiber channel over Ethernet standard, so it's a converged network adapter in that sense. It's been broadly certified by all of the storage industry, so it's there to seamlessly access your SAN. And obviously, from a management perspective, the key capability of this virtual interface card is its ability to be centrally managed and configured so that the configuration of the adapter transpires into the specific configuration of the devices that are visible on the PCI bus of the server. Great technology. I actually really very much like the quote. EMC IT is known for, obviously EMC is known for its reliable and robust storage technologies and certification programs. EMCIT follows those best practices and standards, and they are one of our referenceable customers. Now, the virtual interface card is interesting because it can be combined in different interesting ways with the vSphere platform. So first of all, you can actually leverage the benefits of the programmability of the virtual interface card actually in a pre-boot environment only, which basically means that you create the interfaces that you need to map your management network, your vMotion network, your VM network, your PC over IP interfaces, your iSCSI interfaces, if that's the case. And then you run vSphere on top of that. Then the value is that you don't have to effectively worry about how many adapters and HBAs you need to deploy into the system, because you have a universal solution that can be configured centrally via the management tool on a lights-out basis and then run the hypervisor. And then you can still have all the benefits of the VNLink technologies by simply running the Nexus 1000V on top of UCS. But you can also combine it in a deeper way with the VMware technologies in a combination that's also available in shipping, which allows you to deliver the VNLink capabilities in hardware. So what we're doing here is we're eliminating the need to have a virtual switch. And the reason we can eliminate the need to have a virtual switch is because we can create a number of virtual interfaces that appear as distinct devices on the system, and then dynamically associate them one-to-one to a virtual machine. We're still going through the emulation layer, but you eliminate the need to have a virtual switch. One of the main benefits of this operationally is that it eliminates the need to ever have to trunk in software. And there are a number of you, there are a number of our customers, and therefore likely a number of you in the room, who are into a situation where you still don't have the ability to trunk VLANs and a large number of VLANs into your hypervisor layer. This provides you the ability to do the solution in hardware. This also obviously has performance benefit in isolation, suppressing broadcast traffic across different VLANs. And then this finally has a performance benefit because it simply eliminates the need to have the switch. And then there's a third mode that's also available in shipping, and it's basically combined with a technology that VMware's had for a while called VM Direct Path. And VM Direct Path is actually a compromise. You effectively trade off the encapsulation properties of the virtual machine for the ability to effectively pass directly, securely, but directly, a PCI device into a virtual machine, running the native driver of that PCI device into the virtual machine itself. And that's what's called VM Direct Path. And because the virtual interface card scales, we can create as many devices as we need and associate them using the VM Direct Path technology natively into virtual machines. And some of the great proof points of the value of that technology is when it comes to network services. You can now run network services like reverse proxies and load balancers at line rate at 10 gig in VMs, something that you cannot do otherwise. And we have white papers published with partners to show that. But again, this is a compromise, right? Because you gain in performance, but you lose in encapsulation. You also lose in mobility. And so we've been collaborating with engineers from VMware to try to see if we can resolve the compromise, get the maximal performance, but also get all of the benefits of mobility, vMotion, and encapsulation. And I want to preface, when I'm going to talk about this slide, that this is based on a technology preview of the software. So this is very much the leading edge of what you can do from an I/O perspective. This is also a reflection and testament of the depth of the collaboration that we have between Cisco and VMware. And what you see on the right is a graph that shows the performance of a workload that's basically pumping traffic at 10 gig, right? That's the line rate, while we're moving that same virtual machine through a vMotion operation across the wire. But we start with the VM Direct Path mode. And if you actually break down what happens behind the scenes, this is obviously all automated. There's first a transition from VM Direct Path to emulation mode. Then there's the actual vMotion operation. And then there's another transition from emulation mode back to VM Direct Path mode. So if you think that's easy, you're mistaken, right? Getting that to work is hard. Now, getting that to work is also valuable because it allows you to combine the benefits of encapsulation with the benefits of maximal performance. And if you actually look at the graph closely, what you see is the first transition on the left server from VM Direct Path to emulation mode has a temporary blip, and that's because we have to stop the device. And then obviously you transition to emulation mode. Then the vMotion phase obviously has overhead. You're contending for resources. Then there's another blip which is the vMotion operation, always has had that blip, always will have that blip. Maybe it'll get shorter over time, but it will always be there. And then you very quickly recover normal operations. So leading edge technology, reflection of the collaboration and the innovation that we're driving together. There's a final point that I want to highlight when it comes to UCS, and it's the innovation that we've done in an area that was probably unexpected coming from Cisco around management. And the availability from day one in UCS of an embedded management plane. Really focusing on discovery and provisioning of the physical hardware resources, inclusive of the network interconnect and inclusive of all of the firmware configuration. It's really about providing a better way to provision your hypervisor layer and your physical layer. What's been particularly interesting about the design and the success of the solution is that this is entirely based on a model-driven architecture with an open API. As a matter of fact, we use our own API to write our shell. We use our own API to write our GUI and our management console. And we've had a number of partners writing to that API, as well as customers writing directly to that API. And when we launched UCS, one of the things that we gambled on is that if we built it, they will come. And what we're actually very happy to have is the success of the breadth of that ecosystem. And it's really focusing on delivering a number of solutions, the ability to do built-in discovery asset management so that you know what you have in your environment, the ability to provision an entitled capacity to a particular use. And as we think about multi-tenant deployments that require different degrees of isolation, being able to entitle a particular amount of physical capacity to a particular use with all of the associated networking and security policies is critical. And then obviously finally providing a single point of unified monitoring to monitor the entire infrastructure. So maybe the best way to think about it, what a UCS system looks like, is you can think about it visually as, maybe being a rack. As a matter of fact, you can scale UCS so that it may take up to 4 racks in a data center. Right? So think about 4 racks of gear, all servers and blades, with a unified redundant interconnect in the middle. And that's the physical view. The management view is that you have one web service with a RESTful-like API that can control everything. Right? So that entire capacity is under your control from a management and automation perspective. We cannot stress enough the importance of management and automation. As a matter of fact, that's precisely what, and this is again unplanned, what Paul said earlier today. So again, I mentioned earlier, we were hoping that if we built it, they will come. And the good news is that the ecosystem has come. And what we have now is over 40 ISVs that are writing and investing their time and their resources writing to this API to manage the physical infrastructure. Broad set of range of use cases. The concept of a catalog, right, the equivalent of the App Store, but the catalog in the enterprise is important. The ability, and the catalog applies to all layers, including the hypervisor layers and the OS layers and the application layers. We have the ability through this API to map catalog policies directly onto the UCS, whether it's the network to provision the network or provision the server elements. You can configure and provision UCS directly, and you can drive end-to-end automation through the solution. And then obviously you can build in a monitoring solution, very lightweight, simple monitoring solutions that monitor the infrastructure physically, logically, and by coupling it with VMware connectors virtually. And not only do we have these partners writing software to those solutions, many of those solutions are shipping or are being demoed. As a matter of fact, all of the partners with the green box around them are in some way or form represented at VMworld, either in the Cisco booth or in a partner's booth, as a working solution. And I just encourage you to stop by our booth and check some of these solutions out. So when you think about the value of UCS, it's about performance, balance, scale, management. And it's really something that has significant value proposition as you deploy the solution at scale. And one of the interesting scalability challenges that the industry faces right now is around VDI. And we've actually been collaborating in an initiative. This is actually driven by NetApp, and they deserve a lot of the credit for putting this solution to where it is. And it's basically a solution that qualifies VDI deployments and the best practice for VDI deployment with up to 50,000 seats. The interesting observation of that work is that there's a natural building block that emerged, roughly 5,000 desktops. And these numbers will change over time, but the concept of a natural building block is profound, and that you can create that natural building block with one UCS system and one storage array. And that's not just true with NetApp. That's true with the industry as a whole. So what we should expect for those types of leading-edge, large-scale deployment is these natural building blocks to emerge where you combine best-in-class technology on the compute networking side with best-in-class technologies on the storage side. And this was done with View 4.5. So let me change gears briefly and talk about the innovation that we've done in the area of VM-centric networking. So really specific innovation in core networking products, not the kind of products that are further away from the ones that you would be administering if you're a VMware administrator, but that play a fundamental role in making your life easier at the end of the day. Well, the first one is actually the Nexus 1000V. That's actually close to everyone's heart. And just a couple points about the roadmap and the strength of the roadmap that we have. This is a solution that's been available with every version of vSphere since 4.0. It is interoperable with the new vCloud Director, and we did put the small v in front of the name. And we actually have a pretty strong roadmap with new capabilities that are about to be commercially available, all driven by requirements and requests from customers. So really we're in a mode now where we're listening to customer requests and leveraging our innovation rate by effectively adding networking features, deep networking features, into the core NXOS-based solution that we have with the Nexus 1000V. Now, in 2008 at VMworld, I actually showed this slide, which was our vision of where we were going when we talked about network scale virtualization, going from a state-of-the-art of relatively small clusters to the desire to be able to manage the entire data center as a system, and to then the desire to be able to bridge between the on-premise and the off-premise, or the ability to bridge between multiple data centers and multiple sites. That's sort of what we announced. That's actually exactly the slide that we showed 2 years ago. What we now have as shipping solutions is technology elements that are available commercially at all points in the stack. At the access layer, the Nexus 1000V, but also the fabric extension technology, which gives you scale in how you can connect servers together. In the core of the data center, a technology called Fabric Path, which really is about the ability to have deterministic latency irrespective of where two endpoints might be in the data center. And finally, a technology called OTV, which allows you to have a transparent operation model across multiple buildings on top of an IP network. So let me just go into just one level of detail on two of these technologies. Fabric Path is basically the ability at layer 2 to create a scalable factory. This is a shipping solution with the Nexus 7000 that can be combined with any server, obviously UCS for best results, and really about giving you deterministic latency between any points in that fabric with a phenomenal amount of bandwidth, both from an aggregate bandwidth and a bisection bandwidth. And at the end of the day, the value to a system administrator is that you no longer have to worry about the exact placement of your clusters within your data center. The second technology is called Overlay Transport Virtualization, OTV. So it's fundamentally a technology that takes an Ethernet packet, which is the foundation of networking in the data center, the foundation of networking in vSphere as well, and takes that Ethernet packet and can encapsulate over into an IP packet that can be transparently carried over an IP network. So this really allows you the ability to seamlessly extend your network across multiple sites that have different core network configurations. So if you think about the pains with SRM deployment, probably some of you are running SRM. As we've heard from customers, one of the main pain points with SRM is that you have to keep a mapping table between source, IP addresses on the left and IP addresses on the right. OTV frees you of having to worry about this because you have complete IP-level transparency and the IP address does not have to change. That obviously is the foundational technology to do long-distance vMotion or geo-clustering. And one of the key things is there's a number of technologies that do that. We at Cisco have actually multiple technologies that do that over dark fiber. There are multiple technologies that allow you to do that over a network. This is operationally very different from other technologies you may have heard of because it provides a completely automated and self-managed model. You don't have to get a networking team involved in order to, for example, include a new network segment into the environment as a result of the deployment of that technology. So very flexible and obviously very much designed to solve the multi-data center problem associated with virtualization. So now on into the next session, and this is actually a pleasure and an honor for me to introduce the Virtual Security Gateway. It is a product that's designed to run on top of a virtual infrastructure and to protect the virtualized infrastructure. So it's both a VM-based solution designed to protect virtual machines. And it fits into a distinct location in the security stack as part of a defense-in-depth security model and methodology. And again, we did not cross-reference these slides. This was ironic to see a slide with exactly the same title this morning. And so Cisco has a very broad set of portfolio products that secure the internet edge, which is really about protecting the bad guys and giving people access. We also have products that are focusing on the internal security, which largely was around securing VLAN boundaries. But the Virtual Security Gateway is aimed at solving very specific this new opportunity. I don't think of it as a problem. I think of it as an opportunity to provide a deeper level of introspection and security to a virtualized data center that cannot be available in the physical model. And that specifically is the area that the Virtual Security Gateway operates at. And it operates in a way, and it solves a problem that is designed with operational model in mind. As part of this big transition, which we know is a challenge in a number of customer accounts, which is a transition from a model of operation where you have siloed control, but also siloed visibility, which is the default way of deploying infrastructure physically, to a model where you have shared visibility, but you still want individual control. If you're responsible for network, it's an end-to-end problem. If you're responsible for storage, it's obviously an end-to-end problem. If you're responsible for security, it's obviously an end-to-end problem as well. That transition basically needs to be internalized and incorporated by the products themselves for them to be successful. Because there's no going back into a less flexible model of operation. You still need to be able to go click, 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 get a new VM without any intervention. And the whole self-service provisioning model and service catalog-driven mechanism is precisely premised on the ability to go click, 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 and instantly get a new resource up in the environment. So if you think about the security problem and the state-of-the-art in the security problem, it's largely been over the last 5 to 10 years around policies based and centered around VLANs. Network administrators providing different levels of security and control based on VLANs and stitching together VLANs, providing security rules between them. And you can obviously use VLANs with vSphere today. That's actually a very common way of deploying a vSphere environment. What we're introducing here is something that the industry, and this is not unique to the Cisco solution, this is actually broadly being accepted by the industry as the right way to think about security in the virtual environment, is the concept of zones. And a VM basically is configured more or less effectively when you create it with a certain set of network connectivity elements. But the security membership is an orthogonal concept that is dynamically applied. So you can have VMs from different zones that are connected into different networks. And the zoning determines the security properties for the traffic between the VMs in the zone and obviously between VMs across zones. If a VM comes up, it's going to, based on the policy that you've configured, it's going to join a particular zone. Now, if the security policy gets violated, this could be either manually detected or automatically detected, you need to be able to change the zone of that VM. And for example, if there's a policy violation and you want to quarantine it, what you basically do in practice is you block out all the ports except 22. That gives you the ability to quarantine the VM, and block all the outbound traffic, block all the inbound traffic except maybe one port, and then see what's going on. And the ability to do that without having to reconfigure the VM is obviously one of the key value propositions that's enabled by security at the virtualization layer. And this is something that becomes very important as you have a multi-tenant deployment model. As you move from a relatively flat deployment of vSphere to a more hierarchical deployment model, where you have tenants, organizations, virtual data centers, and virtual applications, you need to be able to manage security policies at the appropriate level of granularity. And very often, for compliance reasons and security reasons, you actually need to instantiate different firewall instances to implement the capabilities. So how do we do this? Well, the Cisco Virtual Security Gateway architecture consists of three distinct components. All of them are in software. They're designed to work together for maximum scale and maximum operational efficiency. So if I start from the top, the Virtual Network Management Center is your single point of policy administration. It can be deployed data center-wide. It's also your point of programmatic integration with APIs. Right? The layer below, the Virtual Security Gateway proper itself, is the actual firewall instance. It is the one that is inspecting flows and applying policies to flows, allowing or denying connectivity. It is implemented also as a software solution. And fundamentally, it implements the bulk of the control plane capability of the solution. And then at the layer below, it's very important for security to be non-intrusive. Right? The best way to get a security solution thrown out of a shop is if it's so intrusive that it impacts performance. And what we've done here is implemented intelligence in the data plane, specifically in the Nexus 1000V itself, so we can offload the bulk of the processing, still have all the semantics associated with the deep protection of all of the traffic, but offload some of the decisions into the switch itself. So the benefits are, A, it's actually a scale-out software-based solution. Right? Both the VM, both the VSG as well as VNMC are VMs, and they're designed for scale-out deployment models. VNMC typically have one or a pair because it's your single point of policy administration. But the files will scale based on either your network scalability requirements or, more importantly, based on the multi-tenancy requirements that you have in your enterprise environment. The firewall is specifically designed to run on top of vSphere and to take advantage of the capabilities of vSphere. So, for example, because it's a VM, it could be rescheduled. DRS, HA, all of the high-end capabilities of VMware apply to the firewall itself. It doesn't consume more resources, not to be managed as a separate set of capabilities. It's also designed specifically to solve a VM-centric networking security problem, establishing zones of trust. Obviously, the decisions that get made in the policy enforcement is irrespective of location. The firewall can move, the VM can move. There's no impact on the security policy, including the advanced security policies that we implement. And then because it's a software-based model, it enables a very flexible scale-out model. On the management side, what we have is we're creating a tool that provides the network security team with a virtualization-centric view, deeply integrated into Virtual Center with real-time update on the content, that provides the ability for that security team to manage security from their perspective. Manage security, update security policies, and take action if that is required. All designed with policy-based administration in mind. You manage via policies and policy settings, and you don't manage by explicitly configuring a virtual machine, or lo and behold, something related to an IP address or a physical port. You actually manage by conceptually assigning a virtual machine to a set of policy domains. So when you actually look at the architecture and how it all gets put together, the NMC is the management piece, but it actually plays a role as an extension of the control plane as well. The security gateway is the firewall, and it can be scaled out with any number of instances required. One of the key parts about security, by the way, is that you actually need to log all of your decisions for auditing purposes. And so let's think about what happens when there's a new connectivity. For example, a client connecting into a VM, or obviously another VM connecting into wanting to connect, create a flow, open a flow with a new VM. We will detect in the switch that this is an unknown flow. As a result of that, the traffic will get redirected over the network to the virtual firewall. So we rely on the network and network redirect and network encapsulation mechanism to redirect the solution. This is how you get scale and performance, by the way. It takes a while for the security gateway to make the decision. Depending on the nature of the policies, and over time we'll have more and more complex security policies, you may actually have to inspect a significant amount of traffic before you can allow the flow. When the flow is allowed, obviously the packets get returned to their original location or to the destination of the VM. The VM may have moved, by the way. And importantly, the decision gets cached. And it gets cached so that after those packets have been delivered, so that subsequent packets can then go straight from the network to the virtual machine. This is how you build a scalable security solution that's non-intrusive from a performance perspective. And this is only the beginning of a very deliberate and focused strategy around the delivery and the build-out of scalable cloud services that leverage network-based technologies, network-based properties to build solutions that are optimized for the cloud. And in that context, I want to just go back 1 minute to one of the key building blocks of the VSG offering, which is the Virtual Network Management Console. And this is actually not a traditional top-down management via explicit configuration type model. This is two things built into one, a policy administration point, as well as a policy engine that basically works in concert with delegated policy engines that are implemented within the individual devices. And these individual devices are the virtual firewall instances in that case. And that basically model provides you the ability to think about management no longer as a distinct function from a software stack perspective, but truly as an extension of the control plane. This is how you get scaling in your deployment model. More importantly, this is how you effectively turn individual devices into stateless, centrally managed via policy resources. And it's really a way of pushing intelligence much, much closer to the metal. So the direction that we're going with VNMC is not just to manage the virtual security gateway, but really to provide the ability to, in a unified manner, provision network services coming from Cisco that can be composed intelligently together. And for those of you who've used UCS and that are familiar with the profile-based and policy-based metaphors in UCS, as well as the capabilities that are intrinsic to UCS, you will find this very familiar because basically we're leveraging the management framework of UCS Manager to build the Virtual Network Management Center architecture. This is important because we're going to expand the ability in a virtualized-centric manner to manage network services beyond only the firewall, obviously moving into the full and comprehensive management of the Nexus 1000 V itself, but also extend it into the management of all the network and device policies associated with the compute platforms as well as network services. And think about this in a new world where you effectively no longer have independent islands of technology that get explicitly managed. But what you actually have is a system that operates by having independent policy engines coming from different companies. We're showing here is the ones that are coming from VMware and the one coming from Cisco, designed to work together by managing via policies and by exchanging policies to form a coherent system. And this is how we'll get to build the cloud. Now, to some extent, that vision is already there today. And I'm going to just use a few minutes to give one example of a solution that Cisco is shipping, which really shows the power of the transformation of the migration from the traditional IT model to one of the cloud, which could be, and think of it as a hybrid cloud, either on-premise or provider-based. And this is in one of the key areas that Cisco has technology in, which is in unified communication. So if you have a Cisco infrastructure for your phones, the dial tone, the directory services, your voicemail is delivered by what we call the Unified Communication Suite. And 8.0 is the most recent version of that Unified Communication Suite. And traditionally, Cisco sells the solution by selling appliances that get racked and stacked in data centers and get physically managed. Starting with UC8, we now have a stacked offering, a true stack. Think of it as a software delivery mechanism that combines UC8, virtualized in virtual machines, running on vSphere, running on UCS. And there are a couple of key things that are really worth highlighting is, A, this has unique and deep requirements because these are real-time applications. And they are real-time applications with all the implications associated with that with respect to the quality of the service delivered, but also with respect to the security and the availability guarantees that you need to provide. I always get reminded that this is also how you dial 911. So this is a real-time stack running virtualized in VMs. You can deploy it in your own data centers. And if you have a large enterprise campus with lots of phone, or if you have a complex call center deployment, this can drive tremendous consolidation benefits because you combine the efficiencies of UCS at the platform level and the wiring level with the efficiencies of vSphere with the ability to effectively run the same thing. You're not changing the stack, the software application itself. You're changing is the implementation cost associated with that implementation. And the reason why this is brought in the context of the cloud is that this can also be delivered off-premise. And we're actually working right now with service provider partners that will be able to deliver dial tone as a service, enterprise voicemail as a service, using the same technologies, by leveraging the intrinsic multi-tenancy capabilities that you can get out of UCS and vSphere once you put them together. So to me, this is a great proof point of where we actually are already today in this transformation to the cloud in an area as important as communication. My final thoughts. First, we have a number of great sessions. We actually have a number of them that were held yesterday that are not shown here. We have 2 great upcoming sessions, one to go deeper into the Nexus 1000V, the other one around panel session around PCI compliance. And then the other comment is I certainly strongly recommend you to stop to the booth. Everyone in our team will be there. I'll be there for part of the time. There are 18 live demos at the Cisco pod, focusing on different use cases, really demonstrating the convergence and the combination of VMware's innovation and Cisco's innovation. Thank you very much.